So y is equal to 5 over 2. That's our horizontal asymptote. Vertical asymptote is negative 1/2, so that's going to go right here. Sorry, yeah. X is equal to negative 1/2. Y-intercept is negative 3, so that's right here, right? 0 comma negative 3. And then your x-intercept is going right here, 0.6, which is 3 over 5. Okay, there we go. So our function is going to pass through our x and y intercepts, and you're going to see that it's like this. Okay, does that make sense so far? So that's how you're going to draw this graph. Okay, so if you want to check, so I think a lot of students may want to know about this. So let's say, how do you know if your rational function, you're supposed to draw it here, and like if you're supposed to draw it here? Well, I think it's very kind of obvious that if you have an x and y intercept on this side, right, your function needs to be there, because that means you're going to pass through your x and y intercepts. But let's say, how do you know that you're graphing this part of your function over here as opposed to, over here? So if you have, let's say, negative 3, so pick any number that is before negative 1/2, so let's say negative 3. And if you try to plug in negative 3 in your function y is equal to 5x minus 3 over 2x plus 1, maybe we can do that. So we have 5 times negative 3 minus 3 over 2 times negative 3 plus 1. You're going to see that if you plug in negative 3, which is before negative 1/2, because you want to observe what happens to your function as you go from the left side of negative 1/2, right? What happens to your function here? So you can do a test run. So if you plug in negative 3 here, or any number, it could be negative 5, right? As long as it's before negative 1/2, you're going to see that your y value, if your x is negative 3, your y value is a positive number, which is 3.6. So that means if it's before negative 1/2 or the left of negative 1/2, your function needs to be positive. That's why you're drawing this up here. Does that make sense? So that tells you that you're having your function here as opposed to here, right? Does that make sense? And the same thing applies here. So say, for example, you're unsure, even though you have your x and y intercepts drawn. If you try to find a number, for example, you can pick, let's see, since we use 3 over 5, which is 0.6, you can pick 1, right? If you pick 1, so maybe we can plug that in right now. If you have 5 times 1 minus 3, right? So plug in 1 to your function y, and then you have 2 times 1 plus 1. You're going to see that your function, right? If you plug in 1 here, you're going to get 0.67, and that's why it's right here, right? That's why if you have x is equal to 1, it should be around 0.67. Does that make sense? And then how do you know it's going down, right? How do you know it's like below your x-axis over here? So you're going to have to find a number that is in between negative 1/2 and 0, right? That's why you can actually see that it's sloping down. Okay, so moving on to this function. So interestingly, we have an exponential function. And how do I know it's an exponential function? Anytime you see y is equal to a, right, a being your base, raised to the power of x, and then sometimes you have plus c. So in this case, we have negative 1, which is our c. That is an exponential function. So whenever you have an exponential function, you need to also have your horizontal asymptote written down, right? So your c, right, in this case, because sometimes you can just have y is equal to 3x, for example, and then when you draw this graph, you don't really have any c, right? Your c is 0. It's not none, it's 0. So that means if you have just 3 raised to the power of x, your horizontal asymptote is just simply going to be y is equal to 0, right? But here's the thing, you have negative 1. Your c value is negative 1, therefore your horizontal asymptote is going to be negative 1. Okay, so do you have an x, I guess, do you have a vertical asymptote? Sorry, I meant vertical asymptote. But in that case, you don't really have a vertical asymptote because the vertical asymptote only exists for log functions, but for exponential functions, you strictly only have horizontal asymptotes because remember, they're the inverse of one another. So you have -1. Let's plot that here. So that's, sorry, not there. That's 0, right? -1 is right here. Okay, that's where your horizontal asymptote is. So we also have y and x intercepts, right? In our function. So what we can do, let's find the y-intercept first, because all we have to do is really plug in 0 whenever you see an x, right? So y-intercept would simply be y is equal to 3 raised to the power of 0, right? Plus 2 minus 1. So 3 raised to the power of 0 plus 2 is 9. 9 minus 1 is 8. So your y-intercept is 8. So that's here. Okay, maybe I can just write that here. Okay, you guys get the point. And then now we need to look for x-intercept. So for your x-intercept, it's going to be a little bit tricky because your x is actually an exponent as opposed to, just having it as a variable right here. So in that case, you would have y, which is equal to 0, and that's going to be equal to 3 raised to the power of x plus 2 minus 1, right? So what you do is you take -1, you move that over to the opposite side of the equation, or you transpose that. This is going to be equal to 1, and that's, sorry, I guess you cannot see the y-intercept. There we go. So for your x-intercept, going back to this, I said that we need to move -1 to the opposite side of the equation, and then you get 3 raised to the power of x plus 2, right? So how do you bring down your exponent, right? So that's where the log comes in, or logarithm. You're going to have x plus 2 times, right? You can take log of 3, right? That means log of base 10 or log 3, right? And then you have 3. So right now, I'm just going to use log of base 10. It doesn't really matter. So in that case, you're going to divide both sides with log of 3, right? Because you want to isolate just x. Actually, hold on. Yeah, just divide both sides with log 3. You don't really need to expand this, right? So log 1 is actually 0, so 0 divided by whatever log 3 is. You're going to get 0, which is equal to x plus 2, right? Moving 2 to the opposite side of the equation, you're going to see that x is equal to -2, right? So in that case, your x-intercept is going to be right here, which is -2, right? So you know that your function is approaching -1. So you're going to graph something like this. Okay, this is passing 8, guys. You get this, right? And this is 2. That's how your function should look like. Great. Okay, so for part F, we need to graph this function, basically, right? So when you're graphing this function, now it's log, right? So what did I say about log versus exponential function? It's an inverse, right? So we have a vertical asymptote, but here's the thing. You need to make sure you know what the domain is, right? And what the range is. And also, actually, for all of your graphs here, right, you also have to identify what the domain is and what the range is, right? So the range here, we can probably go over that really quickly. Range is going to be all reals, right, in this case. And your domain is going to be all reals as well, all real numbers, because your function is a polynomial function. And similar for part B, right? You know what? Let's just do that. And let's have a red pen. Okay, so the domain for this thing is going to be, so this is for part A. So domain, we have all real numbers, right? And then for our range, it's also all reals, right? Or you can just say negative infinity, comma, positive infinity. Right? It's the same thing. And then for part B, because it's a polynomial function, it's also going to be domain, which is equal to all real numbers, and range is all real numbers. Okay. And by the way, if you're curious, let's see if we can write this in interval notation sign, because I know for advanced functions it's pretty popular. So you would just have to write negative infinity, comma, positive infinity, right? So that's your interval notation. Similarly, you can apply this here. So for a rational function, right, because we have a vertical asymptote and we do have a horizontal asymptote, so when you write your domain is going to be all real numbers. However, you're not including 0, right? Because you're looking at, actually 1, because you're looking at your x value right here. So it's all real numbers, right? Anything but except 1, right? Because you don't have a function at x is equal to 1. So you're going to exclude that. And then your range is going to be all real numbers except 0, right? Because it's everything and you don't have any of your function on y is equal to 0. So that's how this works. Similarly for part D, it's going to be the same thing as this one. However, your 1 and 0 is going to be different. So domain is, let's see, domain is all reals except your x. So your x here in this case would be negative 1/2. And then your range is going to be all real numbers except 5/2. Because your 5/2 is your y, which is your horizontal asymptote. Okay. Now, for this thing, right, your domain is going to be all reals. And then your range is going to be, okay, so because if you look at your function, right, it's not going to be all reals anymore. If you look at your function, your horizontal asymptote is basically at -1, right? So you're only seeing your function if it's at -1, right? And then basically it's anything that is above that, right? Okay, so let me rephrase that. You're not seeing your function at -1, but you're seeing your function above -1. So that means you're not including -1. So this is not a square bracket. So that's the difference between drawing a round bracket versus a square bracket, because if you have a square bracket, that means you're seeing that your function is also included, right? But your function is not included, therefore it's going to be a round bracket. And this is round -1, comma, positive infinity, right? Because it goes all the way up. All the way up until infinity, positive infinity. So that's your range. Now, if we're looking at logarithms, right, you need to figure out what your domain is based on your 8x², right, which is your x value. So we're going to set up 8x² greater than 0. And how do I know that this needs to be greater than 0 and not greater than or equal to 0? Well, if you have log 2, 0, that means it's undefined, right? You cannot have your function at x is equal to 0. That's why it needs to be greater than 0. So when you divide both sides with x, you take the square root afterwards, right? You're going to see that x needs to be greater than 0, and therefore your domain is x greater than 0, right? So as a result, we're going to have x is equal to 0, which is our vertical asymptote. And then we all have to figure out our x and y intercepts from there. We don't have any horizontal asymptote